Have you ever just stared at a wall of numbers and your eyes just glaze over? Yeah. It's kind of like being at a crime scene with 1,000 clues scattered everywhere, but you have no idea where to even begin. Well, today we're putting on our detective hats. We're going to go on a journey from that confusing raw data to clear, compelling visual stories that actually show us the truth hiding inside all those numbers. Okay, let's get into it.
So this right here, this is our crime scene. It's a list of 50 soft drink purchases. Now looking at this jumble of words, can you tell me anything useful? Like, who's the top seller? Who's lagging behind? It's pretty much impossible, right? It's just noise, a total chaotic mess of text. And this is the exact problem every data detective runs into at the start.
And this is our magnifying glass. Our secret weapon, really. Data visualization. It's all about taking that chaos we just saw and turning it into a clear, understandable picture. It's the tool that helps us find the patterns, spot the trends, and basically bring order to the mess. This is how we start to crack the case.
So here's our game plan for this investigation. First, we'll go from that data mess to something meaningful. Then we'll start sorting our first clues by category before we try to tame some tougher numerical evidence. After that, we'll see what happens when two different clues connect, uncover a really shocking paradox where the data seems to lie, and finally, we'll put together our own detective's handbook for visualizing data wisely.
Okay, first things first in any investigation, you've got to sort the evidence. So we're going to start by grouping our clues into some really simple categories and see what pops out.
So we're back at the scene of the crime. This list of 50 purchases. To find the real story that's hiding in here, our very first move has to be creating some kind of structure.
And boom, here's our first big break in the case. A frequency distribution. Seriously, all we did was count how many times each drink pops up. And just like that, the fog lifts. Coca-Cola is the clear leader with 19 sales, Pepsi's in second, and it looks like Dr. Pepper and Sprite are tied for last. We just went from total noise to actual insight in one simple step.
But, we can make these numbers even more intuitive. We can turn them into percentages. Knowing Coke had 19 purchases is good, but seeing that it has a 38% market share, that instantly tells you how big its slice of the pie is. It just clicks.
Now, a bar chart takes our little table and turns it into a visual lineup. All of a sudden, you can see the pecking order at a single glance. The height of each bar just tells the story immediately, making those comparisons totally undeniable. Your brain processes this so much faster than a table of numbers.
Here's another classic tool, the donut chart, which is basically a cousin of the pie chart. So while the bar chart is amazing for comparing the individual counts, the donut chart is fantastic at showing you how each part contributes to the whole. You can instantly see that Coca-Cola takes up the biggest chunk of the market. The main takeaway here is you've got to choose the chart that tells the story you're trying to highlight.
Okay, so we've got categories down, but what happens when our clues aren't these nice, neat labels like Coca-Cola or Pepsi, but are messy, continuous numbers? Let's level up to our next challenge, investigating quantitative data.
Right, so with a huge range of numbers, you can't count each one individually. That would be crazy. Instead, we sort them into bins, or what we call classes. Think of it like sorting mail into different slots. It's a three-step process. You decide how many bins you need, how big each bin should be, and what the exact boundaries are. It's how we bring structure to all that numerical chaos.
And that brings us to the histogram. You can just think of it as a bar chart, but for numbers. Instead of categories on the bottom axis, you've got your numerical bins, like age groups or price ranges or test scores. The cool thing is, it doesn't just tell us how many are in each bin, it actually shows us the shape of our data.
And that shape tells a story all on its own. A distribution that's skewed left has this long tail dragging out on the left side. Think about exam scores, right? Most students might score between a 70 and 100, but a few really low scores will pull that tail out to the left.
And the opposite is skewed right, with that long tail on the right. A perfect example is housing prices. Most houses in a neighborhood might be clustered around a certain price, but then you've got a few multi-million-dollar mansions that stretch the data way out to the right.
And then there's the one we often expect to see, the symmetric, or bell-shaped curve. Here, the data is just beautifully balanced around the center. Things like the heights and weights of a population often fall into this neat, predictable pattern, where most people are right there around the average.
So far, we've only been looking at one clue at a time. But honestly, the most exciting detective work happens when you find a connection between two different variables. This is where the real story is usually hiding.
Okay, check this out. This is a crosstabulation, and it is such a powerful tool for finding those connections. Here, we're looking at 300 restaurants, and we're cross-referencing their quality rating with their meal price. Just by scanning the numbers, a pattern starts to jump out. See how the higher meal prices tend to cluster with the excellent ratings? And the good ratings are dominated by the lower prices. The two variables are definitely talking to each other.
But, sometimes the data doesn't just talk. Sometimes it tries to trick you. So get ready for a twist, because we're about to uncover a case where the clues seem to point in one direction, but the truth? Well, the truth lies somewhere else entirely.
All right, detective, here's a question for you. We have two judges, Judge Luckett and Judge Kendall. We're looking at their records to see whose decisions get upheld on appeal more often. Who do you think is the better judge? Let's look at the first piece of evidence.
At first glance, this seems like an open and shut case. Judge Kendall's verdicts were upheld 88% of the time, and Judge Luckett's were at 86%. So, Kendall's better, right? Seems totally obvious. Case closed.
But wait, a good detective knows that the most obvious answer isn't always the right one. What if we're missing something? What if there's a third clue, a hidden variable that's totally warping how we're seeing the truth? And here it is, the shocking twist. This is a phenomenon known as Simpson's paradox. When we break the data down by the type of court, the conclusion completely flips on its head. In common pleas court, Luckett actually has a better record, and in municipal court, Luckett also has a better record. So how on earth can she be worse overall? Well, the paradox happens because Luckett just happened to preside over way more cases in municipal court where verdicts are just naturally overturned more often. That hidden factor, the court type, was twisting the overall numbers, and it changed absolutely everything. That paradox is such a crucial lesson. To avoid getting misled by data and to make sure you're telling the truth with it, we need a clear set of rules. Think of this as your data detective's handbook for creating effective and honest visualizations.
Okay, here are the 5 golden rules in your detective's handbook. Rule 1, give your evidence a clear title. Rule 2, keep the display simple. No clutter, no distractions. Rule 3, always label your axes. Rule 4, use clear, distinct colors. And Rule 5, keep any legends close to the data they're explaining. If you follow these, your work will be clear, honest, and way more powerful.
So, we've journeyed from a total mess of words all the way to a deep, kind of mind-bending statistical paradox. You now have the fundamental tools of a data detective. You know how to bring order to chaos, how to visualize clues, and, most importantly, how to spot a hidden twist. So the only question left is, as you look at the world around you, what story is your data just waiting to tell?